Greetings and welcome once again to my new calculus channel. I'm John Gabriel. So in the past 5 videos, I've been talking about the mean value theorem, trying to explain it to a lot of, many mainstream math academics who don't understand it, who've never understood the mean value theorem or what it's about. Now, the typical retort that they have is they say, there exists a point zero, but there is no pair A and B such that, this is what I say actually. And if there's a point zero and it's differentiable at point zero, then there ought to be a difference quotient, okay? Because that's how the derivative is defined in the mean value theorem. It's defined as a difference quotient, okay? So, and, by the way, you're looking at part of a book that I don't normally share with the public. And just before I continue, this here is called The Importance of Learning the Right Way. And what I'll show you inside here is actually meant for members only. So you can't see all of it, but I'm going to show you why your ideas are wrong, or try to show you at least. So the mainstream statement is unremarkable, okay? Totally unremarkable. And you might say, "Whoa, you don't choose a point C in a given interval." Well, that's not what I'm doing. I've never done that. I don't care about choosing a point. There's nothing about choosing being done here. It's you're not choosing an interval and you're not choosing a point, okay? So I simply used C equals to 0 in this example because it's an inflection point, and the theorem claims that f is differentiable over the entire interval. Okay, so if you have an interval like this, it doesn't matter what interval you have, it's got to be differentiable over the entire interval, right? But if I bring it, so if I place an interval around this inflection point, there also has to be a difference quotient, okay? Because the theorem claims that it's also differentiable at C, which is an inflection point. Do you understand that? Don't be stupid. Stop and think about that. So the interval itself is irrelevant since there are countless intervals that satisfy the definition when C is not an inflection point. Okay, countless. Let's see. Look here. All these intervals, see, all these AB will work for that one. And if we move it anywhere else, same story here. All of those will work. All of those, okay? Every single one of them. Nothing remarkable about that, okay? So the thing is, there is no interval AB that will work for an inflection point. What does that mean? That means, let's take a little shot of this and I'll explain it to you. So, pay careful attention. Right. That means that if you placed, let's make this slightly bigger, an interval there, it doesn't matter which interval you have. Like I just showed you, look carefully. Open your eyes. God damn it. I'm thinking that I'm still in my GeoGebra. Look, doesn't matter which interval, okay? This ratio, what you call the average rate of change, it's not a rate of change, that's just garbage. It remains the same, doesn't matter what interval you have, okay? So that's not relevant. Now, if you place an interval around this inflection point, there is no difference quotient, okay? So mainstream calculus is telling you that you have a derivative at a point of inflection, but there is no difference quotient. Do you see that? They're telling you it's this, but then it's not that. So they don't understand what they're doing, and they never have understood what they're doing because they're morons, because they do not understand calculus. that would probably be you if you're a math professor or a teacher. I'm addressing you more than your idiotic students. I mean, I can't blame your students for being stupid. If they have a lecturer like you, what can you expect? So if every other point corresponds to any of countless finite difference quotients, but an inflection point does not, one must question whether a derivative is even possible at an inflection point. Okay, so here in our Discord channel, our new calculus Discord channel, in the lobby section, we've had quite a ferocious discussion here. And one of the members brought up an interesting point. He says that this green dotted line that you see inside here, this green dotted line, is not a tangent line to the cubic. Okay, it's not a tangent line to the cubic, yet it is the assumed line from which people calculate these arithmetic means. Okay, in other words, 1 over square root 3 and minus 1 over square root 3 and 1 minus 1 over square root 3, okay, as you see here. And he says the green line is effectively the average of the two red tangent lines that have actually been calculated. But this green dotted line is not a tangent line to anything, okay? There is no tangent line at a point of inflection because there can be no corresponding finite difference which defines it, all right? So this person has obviously understood this and he's gone a few steps further than most people by analyzing it this way. It's actually quite clever if you think about it, because in any normal situation, the finite difference quotient must be parallel or must equal to the slope of the tangent line. So for example, in the cubic where you have the derivative like that, mainstream morons tell you that the x-axis is a tangent line, right? But but then obviously you'd need a secant line which is equal to it, right? But that's not the case here. There is no secant line, okay? So there are so many things wrong with what mainstream academics think. They just don't understand these things. They never have. And of course, these facts show that the mainstream definition of the mean value theorem is flawed. It's often trivial that such a C exists. And if it happens to be an inflection point, the MVT contradicts its original statement. Okay, why does it contradict its original statement? Because the MVT says that it's differentiable over AB. Okay, so if it's differentiable over AB, there must be, at this inflection point, there must also be a difference quotient. There isn't. Okay, so before you open your loud sewer stupid mouth and start talking about choosing this and that, it's got nothing to do with choices. You don't get to choose anything. There is nothing about choosing an interval here or a point. I'm merely showing you that the MVT, as stated in the mainstream, contradicts itself when you're dealing with an inflection point. Okay, and I've shown you why. Look carefully. The size of the interval matters not. Okay, there are many such intervals. We only care that there is such a finite difference quotient. In other words, is there a line parallel? Is there a line parallel to the tangent line? And if you look at this example here, in the cubic, so let's just clear this so we can get a nice clean slate here. So if you look at the cubic, which goes something like that, and that's the inflection point is 0, there is no tangent line there, okay? There's no tangent line. You can't draw that and say that's a tangent line, because a tangent line never crosses at the point of tangency, never, okay? So effectively, you're saying that the derivative there is f of 0, which is equal to 3/0 squared, right? Because the derivative of x cubed is 3x squared. But you're making a big mistake, because there is no derivative at this point here. You're simply assuming that because you can merely place 0 in there, which, by the way, is another topic entirely, it's also a wrong concept and is taught completely wrong. And 0 itself is not a number. It should be taught as a placeholder, not a number. So if you just put 0 in there, you're effectively just canceling out the derivative. You're saying there's no derivative there. when you put 0 there, because no slope means no derivative, means no number. 0 means no number, okay? So my brain is going down maybe a million pathways, which is probably too much for your peanut brains, but I'm trying to explain this. So bear with me. Okay. So you're saying that there is a tangent line there. Okay. There is a tangent line there. But there is no f of b minus f of a over b minus a, which is what the mean value theorem is saying. And you're saying, well, it doesn't matter because doesn't apply to inflection points. Actually, it matters. And it applies to inflection points because read the statement carefully. It says that f is differentiable on AB and C is in AB, you morons. Okay. It says f is differentiable. Well, if it's differentiable at C, then there must be a finite difference quotient. Okay, so not to spend any more time, because if you don't get it by now, you'll never get it. You're just a moron. And by the way, this is one of the things I address in here. In its current form, calculus education causes significant damage to learning and understanding. Significant damage, because it's not about the crap that is stated in the mainstream definition. It's about an arithmetic mean, okay? And I've explained that in many other videos. The mainstream statement of the mean value theorem is completely unremarkable. And it causes significant damage, and misconceptions become deeply ingrained in students' minds. And in most cases, these incorrect notions will remain for life, making them nearly impossible to correct later on. Okay, and how do I know? Because I've seen the numerous stupid comments that are posted on my videos, not just by math educators, but also by the poor students whose brains they totally destroy with their drivel. Okay, do I know better? You bet your boots I know better. I'm a genius. What are you? You're just an average Joe, and maybe some of you might have an IQ of 120, but guess what? Mine's above 160. So you're very, 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 very far beneath me. Don't even think about correcting me. You don't know better than I do. If you're not already a subscriber, become one. And to learn much more and have access to my secret article, Learning the Correct Way, which, by the way, I have on Kindle as well. You can buy this thing on Kindle. If you're a member, though, you get everything free. But I have several fantastic books. And this one here is an ongoing work. If you're a member, you get instant access to the updates. Of course, if you buy the Kindle version, you also will get those, but only when I update the Kindle version. Whereas as a member, you constantly have access to one of these beautiful directories here. Okay, this one here. You have access to this members only, and sorry, I can't show you that. If you want to see what's in there and you want to get more information, you need to become a member, and it's going to cost you €4.99 per month. So hurry up and join. Don't delay. You're also invited to join this Discord where we have many discussions. You can see 2 channels because these are public, lobby and questions, but you can't see the rest. And believe me, there's a lot going on in here which your moronic professors won't even know in 1,000 years, even if they could live that long. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.